Hello, my name is Pocket Pizzutillo, and this summer I've been working on designing a cobalt-free binder to be used for cemented tungsten carbides. Cemented carbides are composite materials composed of hard carbide particles, such as tungsten carbide, embedded in a metallic binder, typically cobalt. These materials are renowned for their exceptional hardness, wear resistance, and ability to retain their properties at high temperatures. Applications of cemented carbides include cutting tools for machining metals, wear-resistant parts for industrial machinery, and drilling tools in the mining and oil industries. However, there are compelling reasons to replace cobalt as a binder for cemented tungsten carbides. Cobalt poses significant health risks as prolonged exposure can lead to respiratory issues and other serious health problems. Additionally, cobalt is relatively expensive, toxic to the environment, and surrounded with human rights issues. By exploring alternative binders, such as iron or nickel-based alloys, we can enhance the safety, sustainability, and cost-effectiveness of cemented tungsten carbides while maintaining their superior performance characteristics. In order to determine a suitable replacement for cobalt, thermocalc software was used to calculate various multi-component phase diagrams to determine suitable compositions which could theoretically replace cobalt as a binder. These binders largely consisted of an iron and nickel base with majority nickel, due to the elements being within a close vicinity of cobalt on the periodic table and thus behaving similarly. Zirconium, tantalum, and niobium were added in small amounts with the hope that the binder would behave as a high entropy alloy and have enhanced properties. Currently, the 6 binders shown have been synthesized, characterized, and mechanically tested, with the 3 highlighted binders being the ones designed as alternatives to cobalt and the rest being used for comparison purposes. The next step is to create a diffusion couple between the tungsten carbide and the binders to examine the interface that is created in order to better understand how the binder will interact with the tungsten carbide. Thank you.